Well, my name is Madhav Sathe. I'm a principal architect at Google Cloud, and I help customers in the financial services sector, particularly focused on banking and capital markets. In today's session, we are going to look at grounding and inferencing for various enterprise needs. We'll look at options right from the fully managed solutions using Vertex AI, or build your own platform using GKE. So that's a high level agenda for the session today. We are looking at overall LLM customizations, take an overview of prompt engineering and RAG. Then we'll look at both the fully managed options from Vertex AI, or we'll also look at the GKE based MLOps patterns for DIY platform. So to start with, I think nobody needs introduction to LLMs. They are game-changing AI technologies for generating text or reasoning and used in various use cases, summarizations, Q&A, text generation, etc. But there is a common problem that enterprises have are these, all of these LLMs are trained on the generic data. So there is a problem of grounding. They can end up hallucinating, they have old information, and they don't really have the enterprise data that your enterprises really care about. So if you look at the overall spectrum of the options that have emerged in the industry and have been adopted in different, based on the different maturity of adoption, we can actually look at this as a metric of complexity versus cost and cost of ownership, starting with prompt engineering right up to the pre-training. I'll give an overview of what these options are, but prompt engineering is potentially one of the most common skill that will industry will actually require as they start adopting LLM. Moving forward, for anyone who needs to customize behavior of the LLM beyond just a prompt engineering and want to use the enterprise data for the LLM with the LLM or integrate with the LLM, then you need to use something called as RAG, which is retrieval augmented generation. We'll take a look at that as well. These are the two most common adoptions that we see in the industry. Beyond that, if you want to start looking at how you actually go and start tuning your models, and there are various options for tuning, then your cost of ownership as well as complexity goes up really, it starts increasing quite rapidly. You need a lot of engineering skills as well as cost to run tuning jobs or run the platforms that can allow you to do tuning jobs in a customized way. And there are a couple of options of fine tuning here. You can actually use PEFT or parameter efficient fine tuning, or a full fine tuning where you train all the weights, all the entire model weights, or you can actually create your own model, which is called pre-training. Now let's take a look at a very high level overview of a few of these options of customization, and we'll jump right into the differentiated solutions provided by Google Cloud. Let's start with the prompt engineering and RAG. At a very high level, prompt engineering is, you can look at it as a science or art and science of asking right questions to LLM. Uh, the prompt can be stuffed with the persona. You can give instructions to it. You can have one shot or a few shot examples. You can also ask the model to share the chain of thoughts, and obviously you can add your input data to it, and in the return LLM will generate a response. Now beyond that, like, this is the most common skill that you will see in the industry quite a lot emerging as LLMs get more and more mature. But beyond that, you need enterprises to use enterprise data with the LLMs. And there are three stages of RAG, or retrieval augmented generation. The first one is called pre-processing, where you get your enterprise data, you break it down into smaller chunks, use your embedding model, and store the embeddings into the vector database. The next process is when the user submits. Now this happens in your data pipeline. You need to have a DevOps and data pipeline to actually make sure that you have a right tools and technologies in place to make sure that the data, newer and newer enterprise data, is continuously fed into the system and vector database is updated. When the user submits a query, you use the embedding model and then find the relevant context. Find the relevant context by virtue of getting the right chunks of the pre-processing that you've done earlier. That's called retrieval. Now here there are various methodologies you can do chunking, and it slowly starts becoming a complex process of what should be the chunk size, how should they overlap on each other, etc. So once all of that is done, you enrich your query, or you can augment your query by adding the relevant context by getting those chunks, and then you submit that to your send that to your model inference and get a response back. So at a very high level, RAG or retrieval augmented generations involves all of these things to take care of. Now, you if you actually start using various models and various versions of your applications, this process can become really complex. You need to own the management of vector database. You need to deploy these embedded models somewhere, manage the versions of the applications, manage the data pipelines, etc. Now, if you're in an advanced stage of LLM adoption, and if your RAG itself is not enough and you want to tune the model itself, then you can start with something called a supervised fine tuning or parameter efficient fine tuning. There, what you do is you take your pre-trained model, which has generic language capabilities and reasoning capabilities, you freeze the model weights and add additional layer called LoRa layers, and use your supervised fine tuning data that are very task specifics. For example, let's say you have three different task use cases in your enterprise: one for summarization, other for classifying data, and the third one to generate generate text. Now, you can have different supervised data that you can use, and you can add a LoRa layer of weights on top of the original model, and then you can use that to serve the specific business need. Now that requires a lot of compute capacity and a lot of engineering effort, and starts becoming really complex. So not every enterprise has the need to actually start supervising or fine tuning the LLM models itself. Now, let us take a look at Vertex AI, which is a GCP's Gen AI solution, a fully managed platform for grounding. We'll take a look at the capabilities. If you look at a very high level, all of these are the MLOps pipeline processes that are involved in creating the RAG application. Now, Vertex AI offers a fully managed experience for you to just get in your data, store it into your object storage, and we give you a fully managed experience for search, which is a grounded search on your enterprise data. And we'll also give you the serving by virtue of having our own LLM models called Gemini. Now, some enterprises need some flexibility. They want to use Vertex AI for managing RAG applications, but they also want the flexibility to customize it as per their needs. So that's where we offer the customization as well within the Vertex AI, and you can pick and choose what exactly of Vertex AI capability you want to use versus where you want to build your own capabilities. Now, we also have something called as blended search, which allows you to combine multiple data sources when it comes to building grounded search. We have a tool called Agent Builder, and we have a solution called Vertex AI Search, which takes advantage of all variety of data sources that are embedded within the GCP. You can use advantage of structured data, unstructured data, or even public web pages, and you can take advantage of multiple data sources or different types of data sources to get the most grounded results or with citations. Now, with that said, I have built an application here for demo purposes, where I will show you the multi-model capabilities of Gemini with generic language capabilities or generic LLM capabilities, and will also show how you can use enterprise data and use grounded search based applications using Vertex AI. This is a very high level architecture. What I'm going to bring in here is financial services specific data that is getting loaded into GCS bucket. GCS is our cloud storage or object storage bucket. And we are using Agent Builder to bring the search experience that is grounded in your unstructured data. I have an application, Streamlit application with Python backend that runs on GKE, and that is what the end user is going to access. Behind the scene, as you can see, all the rack pipeline, different stages of processing, pre-process the data, annotated it, embed it, index and find the nearest neighbor, etc. All of that is managed for you. So what you get here is a fully managed experience, and we'll use the advantage of multi-model Gemini models as well. So take a look at that. So Ron, you'd let me know when I want to switch the screen to a demo screen, and let me know if you can actually see my demo screen. Uh, are you able to see the demo screen now?
Yeah, it says Vertex AI Gemini multimodal.
Yeah. So
Yep.
we'll take a look at multimodal capabilities. We'll start with, for example, let's say you want to use a marketing campaign. So you start giving some user inputs, which will basically feed into your prompt, and you can generate a marketing campaign based on either a Flash model or a Pro model. Now, Flash has a much better latency, and it starts creating a marketing campaign for you. Now, these are generic language capabilities, and you can also take a look at the prompt that has been used, right? How that prompt has been fed. You can also create an image playground, which is like demonstrate the multimodal capabilities in this one. And you're asking that, hey, which chairs are more suitable for work, right? So based on these images, tell me which one is more suitable. So it goes into it and tells you which chairs are more suitable. So it gives your opinion based on images as well as text generation. So it shows the multi-model capabilities. But this is all generic data. This is not grounded based on your enterprise data. You want something that, let's say you're a financial services company and you have a need to build regulatory reporting applications. So what we have done here is we have taken the FINRA website, downloaded some PDFs, and stored that into the object storage. And I'm going to ask very specific questions where I expect the Gemini or model to use the enterprise data to generate an answer. So let's see what it does. And it also should be able to tell me exactly what sources of data was used here. So what you see here is not only we found out a question to an answer. For example, what procedures are in place to reconcile cat reported data with internal order and trade records. So it generated an answer, but the raw data for generating that answer was based on the documentation that we had fed into your grounding sources. Right now, this is a publicly available information on FINRA website, which we downloaded. But you can also have your own enterprise data in the form of PDFs that you can upload as part of your grounding applications. So with that said, let me switch back to the presentation. So that kind of shows the high level overview of Gemini capabilities, multimodal capabilities, as well as grounding capabilities. And because this whole experience is managed, you don't have to worry about managing the vector database, creating embeddings, running the embedding models. All of that experience is fully managed for you. All you have to do is deploy your web application or your enterprise application in a managed containerized environment, and just refer to the uh, inferencing. Now, moving to more sophisticated use cases where customers need a high amount of customization, they want to build your own platforms, right, using Kubernetes, and they do not want to use anything packaged or anything managed from a cloud. In that case, you can use Kubernetes based patterns, and it is complicated. So it is important to make the right choices for optimization. Let's take a look at those. So let's take a look at what are the different components if you want to build your DIY rack platform at a very high level. Let's say you're building an application on Kubernetes, then you at a very high level you're going to have two subsystems: embedding subsystem and a serving subsystem, right? In embedding subsystem, you're going to use some kind of data ingestion pipeline to get access to data stores, to load the data stores with raw data, right? Now in your enterprise, if you're actually a very advanced user, instead of embedding subsystems, you may actually use fine tuning or training the entire model as well. Uh, but essentially, you're going to have those embedding service that will create embeddings in the vector database. And from the front user perspective, from the serving perspective, you can have some kind of a LangChain application for front end tier, which will use semantic search to pull in the relevant context. And ideally, you should have some kind of a responsible AI service which will make sure bad prompts are not sent back to the LLMs, or some kind of mechanism is there to prevent unethical behavior, or behavior that's not suitable for the enterprise or social, from the social aspects, right? And you have an inference server as well. So how does it look like when you run it on Kubernetes and some of the open source technologies? We see Ray emerging as the open source platform for running distributed applications for RAG, or LLM based distributed applications. On a right hand side, what we see here is an embedding subsystem. As you can expect, your enterprise data is getting stored into GCS bucket, and we have a embedding service, which is essentially a Kubernetes cluster, a managed GKE service, managed Kubernetes service, that is running the embedding application. Now it's a Ray cluster. What it typically, at a very high level, you're going to use a data API that is going to take the data from the cloud storage. It's going to shard it, it's going to chunk it, and then use a Ray job to store the vector embeddings into a vector database. In this particular case, we have a managed service called Cloud SQL, and you can use with PG Vector. You can use it as a vector database based on Postgres MySQL service. Now on the left hand side, we have a serving subsystem where we built a, you can build a front end application with LangChain, and behind that you have an inference server that essentially is a runtime for your LLM applications, right? You can run your model that you like, open source model for example, and Hugging Face TGI as your inference server. What we also provide here is a sensitive data protection, so make sure that bad prompts are not actually processed, etc. So you can set up your policies, enterprise policies, and overall all of this can be protected using the identity aware proxy, so that only authenticated users are allowed to access it. So if you want to build a DIY platform for RAG, this kind of be your high level architecture. And we have some cloud documentation links as well in the below. Now slightly double clicking into the embedding subsystems, um, we have two major components here when it comes to embedding subsystems. One is the Ray cluster itself. It's a distributed application that runs on GKE. At a very high level, there are two kinds of node there: Ray head node and Ray worker node. And uh, they are going to use embedding model running on the GKE. And you can use GCS as your object storage for your enterprise data. So read the data from the GCS using something called as GCS Fuse, and I will talk about that very shortly in the next few slides.
Hey,
And
Matt, we've got about 2 minutes or so if you can just plan your time accordingly.
2 minutes.
Yeah.
Uh, all right. I thought I had 30 minutes session.
More like about 20. So let's see if we can just, yeah.
Okay.
Okay. Yeah.
All
if
right.
we just manage it so we can make sure we're just fair to everyone. Okay.
Sounds good. So what we see here is that we have GCS Fuse that allows optimization of your accelerators by not blocking the GPUs or accelerators while the data gets loaded from the storage. You can start streaming the data. You use the file system semantics from the developer perspective. That's a great way to do that. You can use the GCS for your pre-processing as well as checkpoints. So when you're tuning the data, you need often go back to that storage to go and start storing the weights that are used as checkpoints, so you can recover from the failure, etc. At a very high level, when you're talking about tuning and training requirements, you're gonna need a high performance, high throughput GPU to GPU fabric to train or tune the LLM models, where you can actually have that by virtue of having multiple GPUs running on different NICs and listening to working on different VPCs, all of them actually without any choke point talking to each other. So multiple GPU one on different machines, they talk to each other on the same VPC without any hassle, without any choke point. And even across the GPUs, when you want to share those weights, etc., all of that can be done using a high level network abstraction called NCC, Network Connectivity Center, where you do not have to do VPC peering to actually have the weights and model, computations shared across multiple GPUs. On the north side, we have a CPU that actually needs to share those periodic snapshots or checkpoints to the storage. So we have a separate network there. Now, when it comes to GKE, we support that kind of topology by virtue of having a multi networking GKE. And in typical scenarios, when you're running tuning and training, your GKE node will be occupied by the pod. Instead of having multiple pods, and each of the pods can actually link to multiple VNICs, right, on the machine. And essentially you can take advantage of the 8 GPU networks and one CPU network that is available for the storage and checkpoints. So that's extremely high throughput that you can get, and network bandwidth that you can get. And we have a couple of machine shapes as well, A3 Mega, A3 Ultra, that allows you to do that kind of networking. uh, you can have a large container images using secondary boot disk. So when you have a container images, you don't have to continuously download it from registry and slow down the inferencing process. And it having a secondary boot disk attached to the GKE node pool, it essentially a near constant latency at a massive scale when you talk about big container images. In the end, I would say serving needs are very different for traditional web applications and LLM based, Gen AI applications. So their load balancing needs are also very different. And we have programmable extensions that you can use, as well as a cube depth based or headers in the response that can smartly load balance across multiple GKEs clusters based on where the load is. So that's essentially the high level of managing your own DIY platform on Kubernetes or managed Kubernetes using GKE, and some of the patterns for that. So that's essentially the end of my session.